Alright, this is your Unit 3 study guide. I might make some mistakes during this as I'm recording this video with the flu, but want something for you to have. Also, the handwriting slash screenwriting is not going to be the best because I don't have my tablet with me. I'm doing everything on my touchscreen laptop. But here we go anyways. Number one, we have g of x is equal to 2x minus 1. And they want us to evaluate the x values of -3, 1, and 2. So this is just like when we would make an xy table. So -3, 1, and 2. So from here what we're going to do is these are your x's. So we're going to put these x numbers into the actual equation. So we're going to do 2 times -3 minus 1. We're going to do 2 times 1 minus 1. And then we're going to do 2 times 2 minus 1. And so if we do the order of operations, we get our answers of -7, 1, and 3. So then what we want to do with those numbers is we want to put those on a graph. And so these are not going to be exactly perfect. We're not going to take the time to do that because you have the graph paper on yours. But our first point, which was located at -3, -7, so I'm going to go left 3, down 7, so that's somewhere around here. The next point was at 1, 1, so I'm going to go over 1, up 1, so that's right around in here. And then finally 2, 3, so I go over 2 and up 3, just right around there. And again, this is not going to be perfect. But then you're going to connect your dots, and you have your line. You've just now made the equation, or you made the line from the equation. Okay, for the next one, which is a word problem, which I'll be able to type some of my answers in this time. It says that if we write down all the important information from the problem, it says that a plumber's fee is $60 for a house call, so 60 for a house call. It also says it's a $25 an hour charge while there, and we are supposed to answer the parts about this. So let's go straight to part A. For part A, it says, what is the independent variable? Well, remember, when we do independent and dependent variables, let's identify the variables first. The variables themselves are the things that change in the problem. So the hours will change and the money paid out will change. So now let's make a statement. Do the hours depend on the money, or does your money depend on the hours? And the money paid out depends on the hours of work. And so what we just said is that the money paid out depends. The money paid out depends, which means money is the dependent variable. So for A, when they want to know the independent variable, it is hours. When they want to know the dependent variable, it is the money paid out. So C is asking for the function notation equation. Well, sometimes it's easier to start in regular equation. So the money you pay the plumber is equal to the $60 house call. So whether they stay there 30 minutes or 30 hours, you have to pay them $60 right off bat, plus the $25 plus the $25 per hour. So in function notation, that would be the following. Remember, the first letter of function notation is just the name of it. So let's call this P for the payment that we're going to give the person. And then in the parentheses is always the input or the independent variable. And in this case, the independent variable is the hours. So then the last part of the function is the actual, the expression, the job. And the job is to take the hours and multiply them by 25 and then add 60 to it. And then we get our function notation. D then asks for if the plumber charges you $185. So $185 is not the hours, it's the money that you get. So 185 is equal to, and this one, you know what, I'm actually going to write so that we can see it being solved out. So for D, come up to here, the 185 is the money that you got, the money that you're going to pay, and that came from the job of 25H plus 60. So now we just do some of our solving that we learned last chapter. So we get rid of the standalone number first, so we subtract 60. And that gets us down to 125 is equal to 25H. Then from there, we're going to divide both sides by 25, which is going to give us our final answer of 5 is equal to H. So it took 5 hours, or means they were there for 5 hours if our bill was 185. All right, now for the next problem, number 3, we have to make a mapping diagram from the data table. So let me get it back up to here. So in our mapping diagram, so this is number 3, we have the inputs or the x values, and then they have the y values or the outputs. So our inputs, we usually order them from smallest to least. So we have negative 3, 2, and 5. Notice I did not put the number 2 twice. Even though it's listed twice in your table, you only write it once. And then our outputs, if they put them in order, is 4, 7, 8, 10. And the way I like to do the diagram is I go in order so I don't forget anybody. So the first point in your table is 2, 4. So that means 2 goes to 4. The next one is negative 3, 10. So negative 3 goes to 10. Then 5 is matched with 7. So 5 goes to 7. And then 2 goes with 8. Well, 2 is already with 4, so if 2 goes with 8, we have to put another line coming out of 2. So that's the first part. The next part then says, state if this is a function. So again, on your test Friday, you can't just say function or non-function. You have to do the following. This is not a function because the input of 2 is pointing / with 2 separate y values. Or as we talked about in class, the button on the machine is unreliable because sometimes you get a 4 and other times you get an 8. Alright, now we're on our next page, page 4, which is another word problem, so we're going to take a look at it and break it down. Again, some of the best things to do is just write down what you know. So as I'm just scanning over this, I see that we are going to be raising money by selling roses. So we're selling roses to raise money. The next thing I see is that cost of each rose is $1.50 plus a delivery fee of $25. And then it says we are going to sell the roses for $5. So let's get down our things. It says define a variable. So what's changing here is we don't know how many roses. So I'm going to say roses is equal to X. We might decide to sell 10 roses, 20, 30, who knows. So roses is X. Then B says write a cost function. So I'm going to call this function C, C for cost. In order to figure out the cost, you have to tell me the number of roses. So that's our independent or our input. So C of X is equal to, well, no matter how many roses we buy, we've got to pay the $25 just to get a delivery. And then we're going to add on $1.50 for every single rose. So if I bought 1 rose, it would be 25 plus 150 times 1. If I bought 100 roses, it would be 25 plus $1.50 times 100. Then it wants a revenue function. Revenue is saying how much money you made from your sale. It's not your profit, it's just how much money did you collect from your customers. So I'm going to call this R. So the only way to figure out how much money we collected from the customers is to figure out how many roses we sold and multiply that by what we sold them for, which was $5. So 5x. D, the most important, is your profit function. Your profit function is equal to how much money you collected, which was R of X, minus your expenses or your cost is, so minus C of X. And that is perfectly fine. But for bonus points on Friday, if you simplify this to 350x minus 25, you would get bonus. And the reason it's 350 is if a rose you sell is $5, but it costs you $1.50, you make $3.50 off of each single rose. But at the end of your sale, you can't forget to subtract the $25 that you owe the delivery from the florist. All right, number 5. It says we have this whole word problem, and it says in there that we've got it says that c of x is equal to 36x. So we know that x is the input, and we know that this is the job of our machine. And we know that c is just a random letter for this. Usually it's not random. We try to use letters that make sense. So let's see what this is actually talking about. This says that the cost to manufacture is X chairs. So that's important. X is chairs. And since X is in the parentheses, that means X is your input and those are your chairs. So when they come down to C of 63 is equal to 2268, well, that just tells us a lot right there. It's telling us that when we plug a 63 into the question, into the equation, when we plug this in, this is the number that comes out. Input, output. So in that first box, you are going to circle a 63, and then in that second box, you are going to circle 2268. Moving on to number 6. Number 6 is asking for you to pick the ones that are not a function. So you're looking for your list of ones that have the buttons that your buttons that are not working. So I'm just going to list the ones that don't work and give you why it doesn't work. So this is question 6. Okay, the first one is the second selection, because button 1 gives you 3 and button 1 gives you a 7. The next one that does not work is the fourth selection, because 1 gives you a 1 and then later 1 gives you a -1. The next one that doesn't work is your sixth selection, because 3 gives you a 7 and 3 gives you an 11. And finally, the last one that doesn't work is seventh selection, because 9 gives you a 15 and 9 gives you a 19. And again, just because on the study guide it says find the ones that are not functions, doesn't mean on the real test I might say find the ones that are functions. So also make sure you read carefully on this test. So the next one says 7, what are the things we use for the variable x? Remember, x's are what go in the problem. So we go with input, domain, and then our independent variable. Since the x is what always goes in, all these words have in for in, which makes that nice to remember, because then when they ask you for all the things that represent the y values, those are what come out of the problem. So output, range, and the dependent variable. So those are 2 just vocabulary questions is all you need to know for those. Okay. Next one we have, again, function notation. So we have h of t equals -3t plus 10. And then it tells us h of t is equal to 20. So if we take a look at this, the number that they give us the second time around isn't in the parentheses. It's the number on the other side of the equal sign. So that means we don't know what the t value was, but we know what came out of the equation. So this one is different, and this is the most missed question every year, so make sure you pay attention. this is where the 20 came out. We don't know the t value. So we don't put the 20 in for t because right now there's nothing there for t. So the 20 is what equals negative 3t plus 10. And now what we're going to do is actually solve once this scrolls. Again, sorry for the tech difficulties here. I just don't have my tablet. So we're going to get rid of our standalone by subtracting first. So I do not have negative 10. I have a positive 10. So positive 10 equals negative 3t. To get rid of the negative 3, that's a multiplier, we divide. Well, negative 3 is not going to go into 10, so that's great. So we just say t is equal to negative 10 over 3. Next one, 10, it says, what would y have to be in order to disqualify the thing from being a function? So in the beginning of the problem, this is number 10. You have 2 comma 5, and then later you have 2 comma y. Well, if y was a function, if this was a function, then y would have to be a 5 again, because that means button 2 gave you 5 at the beginning, and then it gave you another 5. But since they don't want a function, y needs to be anything except 5. Number 11, I'll do a quick sketch. So here's once I click here, we've got our XY axis, here's the picture, and it says, is this a function or non-function? This would be a non-function because I can draw a vertical line through it, which means this point here and this point here have the same x coordinate but different y coordinates. And so this fails the vertical line test. So if you just write that, fails vertical line test, that's fine. All right, on to, and that was actually number 11. Now we're on to 12. For number 12, they give us a whole bunch, and I'll let you read it through. But in the end, we are trying to get the distance that we would travel if we know our speed and we know our time. And so distance is equal to rate times time. So the rate, our speed, is 3x squared plus 2x minus 1. And then our time is 2x plus 5. So I'm going to have to multiply these. And this multiplication was one that a lot of us still struggled with on the quiz last week. So when you have this, this is where you go and use your box method. So we are going to, in just a second, there we go. We're going to make our box. We're going to have 3 columns for our 3 numbers. So 3x squared, 2x minus 1. We're going to have our 2 rows, which is 2x and 5. And now we're just going to do the multiplication. 3x squared times 2x is 6x cubed. I want a different color. So 6x cubed. 2x times 2x is 4x squared. 2x times a negative 1 is a negative 2x. 5 times a 3x squared is a 15x squared. 5 times a 2x is a 10x. And 5 times negative 1 is negative 5. So if you get to that part, you'll probably get partial credit for your answer. But to get full credit, we now have to put together the like terms. So our like terms start here at 15x squared and 4x squared. Then the other pair of like terms start over here at negative 2x and positive 10x. So if we combine, we have our regular 6x to the third. We end up with 19x squareds. Notice that the variable and the exponent don't change when you add or subtract because you're just adding or subtracting an amount of something like a fruit on your grocery list. And a 10x and a minus 2x make an 8x. And then we have that plus 5 at the very end. Actually, no, it's not a plus 5. That is actually a minus 5. There we go. All right, on to the next page. And on this next page, I'm just probably gonna, on 13, I'm just gonna type these in. Um, so actually, let me just do a visual real quick. So if this is your graph, and this is the curved line that goes through it, there are two special points on this picture. The first one happens right here. This is what we call the y-intercept, because it's where your picture crossed the y-axis. The second point that is special is right here, because this is the point where you cross the x-axis, so we call it the x-intercept. So now let's answer some questions about these. First, A is x-intercept, if you fill in the blank. B is the y-intercept. And then C asks you, for all y-intercepts, what is going to be the 0? Well, if the y-intercept is always on the y-line, it never went left, nor did it ever go right. So the x-coordinate is always 0 for a y-intercept. Vice versa, in x-intercept, which is right here, it never went up or down. So the y-coordinate will always be 0 for an x-intercept. 14, we get into function operations, which is what you've done, you've been tested on, but now instead of it being fully written for you, you have to write it down yourself before you do the problem. So it says find r of x plus a of x. So r of x is 5x squared minus 2x plus 4. And this is question 14. Sorry, I haven't been writing them down. And then a of x is 4x squared, so we're adding, which means, so when you add another function, none of the signs will change. It is what it is. So the 4x squared stays how it is, the 9x stays how it is, the minus 3 stays how it is. If this would have been a subtraction problem, that's a big if there would have been a minus sign in between these, then it would not have been plus 4x squared, it would have been minus. It would not have been plus 9x, it would have been minus. It would not have been minus 3, it would have been plus. But this was an addition problem, so on addition problems, the signs don't change. Subtraction problems, the signs change. So let me get rid of those. So now let's actually do the combining like terms. 5x squared, 4x squared gives us 9x squared. Negative 2x and a positive 9x gives us a positive 7x. And then a positive 4 and a negative 3 give us a plus 1. All right, moving on to part B. Part B wants us to multiply. It says 3 times the function f of x, or r of x. I guess it's an f. So we're going to go 3 times f of x, which is 5x squared, minus 2x plus 4. So this is just your distributive property. 3 times 5x squared is 15x squared. 3 times negative 2x is negative 6x. 3 times sloppy handwriting of 4 is a plus 12. And then that would be your final answer. Moving right along on to C. C is multiplication. So you're multiplying y minus 3 times y squared minus 3y plus 7. So instead of me writing it all down, I'm going to go straight to the box. So one of them has 2 terms, a y and a minus 3, so I'll make those my rows, the y row and the negative 3 row. And then the other function had 3 terms, so I'll use 3 columns. So y squared minus 3y and positive 7. So now let's do the operations. Y times y squared is y cubed. Y times negative 3y is negative 3y squared. Y times 7 is 7y. Negative 3 times y squared is another negative 3y squared. Negative 3 times negative 3y is a 9y. And negative 3 times 7 is a negative 21. But we're not done. Now we've got to combine like terms. So I've got some y squareds that I can combine. And I also have just some regular y's that I can combine. So you end up with y to the third. Negative 3 makes a negative 6, y squared. 9 and 7 make a 16. And then finally a minus 21 at the very end. All right, on to page 5. On page 5, you need to look at your graph and follow along with me. I'll put a really quick sketch of it up here. Again, it's not going to be the prettiest. So this is question 15. So boom, boom, and it goes something like this. And this says distance, and this says elevation. And we're throwing a frisbee. So part A asks first off, is this linear or nonlinear? Well, nonlinear means it's not a line, which we see it's definitely a curve. So this is non-linear. B then asks, do you have a function? Yes, it passes the vertical line test. No matter where I draw vertical lines through this thing, I never hit my picture more than once. One time, one time, one time, one time, one time. So this does pass the vertical line test. C is not the best question. This was copied from Algebra Nation. So here's the, technical answer if you don't overthink it. The y-intercept, according to the graph, is 0, 0. And then they ask you to explain what this means. And so we would say, which is the starting height of the frisbee? But if you think about it, if you're throwing a frisbee with a friend, the height isn't going to start at 0 because you don't start the frisbee on the ground when you throw it. You start it at waist level usually, so you're going to be at least 2 to 3 feet off of the ground. But according to their graph, that's what we would put. But if you went further above that and did some critical thinking and said, on the test, if there was a mistake like that and said, well, their y-intercept doesn't make sense, you might get some bonus points or something. All right, D then asks, they give you the equation, and they want to know what does E of F represent. Remember, E of F is function notation, so they're not asking what F is, they're asking what E of F. And that part, E of F, always represents the output, which is always the Y value. So the Y values in this scenario is elevation. So E of F will give you the elevation of the frisbee. Then on E, they actually ask you, or D part 2, whatever, it asks you what does the F represent. F is in the parentheses, so it is the input variable, which are always the x coordinates. So therefore our answer, so this is just all leading up to the actual answer, there's 2 O's. So the x coordinates on here is distance in feet. So this represents, so F is the distance in feet the frisbee travels. Okay, page 6. Again, I will do a rough sketch of this, but it'll be better and easier if you look on your actual paper. So boom, boom. So this starts at 3 up here. So this is 3, and then it goes down forever to the left and down forever to the right. So here we go. And this is the point here. This is actually the coordinates. Let me put the real coordinates. It's -2, 3. So -2, 3. That's this point right here. So let's put down our answers. First off, it says define the domain. Remember, domain are your x values. So list the smallest and the largest. Or if you think about what x's do, x's go left and right. So the other way is to list the farthest left and farthest right. Well, this thing, farthest left, it never stops going to the left because of that arrow. So you will go all the way to negative infinity. And the thing goes all the way to the right, so you never stop there, so it will go all the way to positive infinity. Now B asks you for the range, which are your y values. So list the smallest and largest, or list the bottom to the top. Or we could go, let me not use that, let me go list the lowest to the lowest down to the highest up. So if we go all the way down, we never stop because the arrows are pointing down. So you go all the way to negative infinity. But as we are going up, we don't go up forever. We stop right here. We don't go past this point. So this point has a y value of 3. So we stop at 3. So we go from negative infinity to positive 3. The next thing, it says, where's the graph increasing? Increasing, we read a graph from left to right. So as you're going on this graph from left to right, we start here. So left to right, right here, we can see that we are going up. Our car would be going up from left to right. So that is our increase section. So this right here is our increase section. So where is it increasing? It is increasing for all the x's before negative 2. Or we can write it as x is less than negative 2. The decrease section is when you get to the top and now you start going down the hill, down the mountain. So you don't start going down the mountain, hill, whatever you want to think, until after you pass negative 2. So we would say it is decreasing after negative 2. Or if we want to write it in correct symbols, we would say it's decreasing when the x's are bigger than negative 2. E maximum, a maximum is when you hit a highest point on a graph, which happens right here. So we have a max at negative 2, 3. Now that's good for Algebra 1. Technically, technically the maximum is just the y value of 3. And finally, relative minimums. No relative minimums, because we never get to the lowest point on the graph. And remember, when you have a minimum or a maximum, you have to change directions. So you have to go from going up to now going down, or going down to then going up. All right, finally, last page, closure property. Closure property states that what you start with, you always end with. So if we look at 17, it says if you start with positive numbers and you subtract, you always end with positive numbers. That is false. And here's your counter example. Here's your example. Because, sure, 10 minus 2 equals 8. I started with positives and I ended with positives. But if I flip it, 2 minus 10 equals negative 8. Not good, because I ended with a negative. So that was false for having closure property. 18 is true for closure property. It says that when you when you add polynomials, you always end with polynomials. Correct. Because you can't add a polynomial and magically have the variable go to the denominator. Because we said that to be a polynomial, you can't have variables in the denominator. So when you add x's or y's or w's, they're going to stay in the numerator. They're not going to move down. It's never happened before. All right, 19. So here are the summary of how you transform any kind of graph that you want to do a transformation. When we start with basic, what we call the parent picture. The parent function is always something of x, so I'm just going to go f of x. If we decide to take f and then on the inside put in x minus 2, that is going to move us 2 to the right. Whatever the original picture looked like, it will move it 2 to the right. All the points move 2 to the right. If I do f of x plus 2, it's going to move me 2 to the left. So it's counterproductive to what you think it's going to do. It actually does the opposite direction. So we'll key in on that in just a second. Now, if I decide to put the number on the outside, like if I put a -2 on the outside, not inside with the x, that will move me 2 down. If I put a +2 on the outside, that will move me 2 up. So here's the key takeaways. When you're looking at this, if you actually go into the x group and mess with the x group, you're changing horizontal movement because the x's control the horizontals. If you are on the outside of the x group, then there's only one other group that you're really messing with. If it's not the x's, it has to be the y's. So the outside number controls the y values. But how are we going to remember which one does the opposite and which one does the exactly what you see? Because when we're working in the x group, the horizontal motion was the opposite. You see a +2, so you go, oh, right to the 2, but it's actually left. So here's a nice trick. If you write the word horizontal, it has an O in it. O for opposite. So if you can remember that you're doing horizontal motion, you can remember, oh, if I see a +3, it's not 3 right, it's actually 3 left. If I see a -8, it's not 8 left, it's actually 8 right. So if you know you're messing with the horizontal motion, you know it's the opposite of what you see. Just like for vertical, it's not that. And let's write the word vertical. Because if the number's on the outside, that dealt with the vertical motion going up and down. And it's exactly what you saw. Oh, look at this. Vertical has an E for exactly. So if you have f of x plus 9, now see how that 9's not with the x, so it's not dealing with horizontal. It's not in the horizontal group. It's not in the horizontal group, so it's in the vertical group. So that means, and it does exactly what we see, so this means it goes 9 up. But if it was a -9, it does what you would think a minus does, brings you down, so this would be 9 down. The last thing you need to know is what happens if we put a negative sign in front of the function notation. So instead of f of x, if I write negative f of x, well, that's going to take a picture that, let's say, looked like a smiley face, and now it's going to reflect it over the x-axis and make it a frowny face. So when you see this negative sign in front of everything, this is what you write: reflection over x-axis, aka flips it upside down. So if you write flips it upside down on the test, I'll take 1 point away from your answer. For full credit, you have to write reflection over x-axis. Now, there are other ways to transform that I know you might have taken notes on, but these are the only ones I'm going to give you on Friday's test. So let's take a look at 19. So the original picture is on the left, and we're going to call that f of x. Now look at the picture on the right, and let's write down what has happened. So let's look at that turning point. The first thing I see is that we have flipped it. So I'm going to write a flip. We've done that. It was a smiley face, but now it's a frowny face, so to speak. Then I notice that the turning point, like where we switch from going down to up or up to down, I notice that it's now 1 to the right of the original. So I'm going to say 1 right. And I also noticed that it's moved up 2. So 2 up. Once you have that, you don't need to look at the picture ever again, because now we know our rules. If we want a flip, we put a negative in front of the f of x. 1 to the right, that is a horizontal motion. So I have to be inside with the x, because that's who controls horizontal. Horizontal has an O in it, O for opposite. So not +1, but -1. And then finally, 2 up, that's your not horizontal, that's vertical, so you're outside of the group. And when you're vertical, you do exactly what you would think. So if you want to go up 2, you do a +2. And for our last question, it says we want to move the graph 2 units to the right. So that's horizontal again. Right, you would think plus, but it's actually the opposite, so -2. And it says we want to go 5 units down. So we hit a -5 as our outside number. And that is it. Sorry again for the quality, but hopefully this helps tomorrow while you're reviewing.